Okay, so good afternoon, everyone. Good afternoon. Right. Today we will be continuing this topic, which is center of mass. Right. Okay. So how many of you message to yes? Here only Sampada message to host only. Okay, everyone, please message to host. I guess all of you remember this concept. Tell me. Right. Remember what we covered in last class. Raise your hand. Right. Tell me. What is center of mass, right? What the different center of mass? We have covered these things in last class. I hope all of you at least remember these concepts, hai na? Yes or no? Yes. Chalo. Awesome. Now, before starting this, let us talk about some basic ideas, some basic concepts that is used in center of mass. Okay, but I guess all of you, yes. So I'll just revise. Okay, I'll just recall what we have covered in last class. Okay, so yeah, we covered these concepts. What's the basic definition of center of mass? How to find the center of mass for discrete system and for continuous system. Right, everyone? Raise your hand. Right? Hi, Anna, raise your hand. Okay, chalo. Yes. So let us start with some recall test. Let us see some recall test. Okay, tell me. Yeah, potential energy is defined for conservative field only. Potential energy is defined for conservative field only. True or false? Everyone. Tell everyone, John, we'll have this. True or false? Raise your hand. Ankit, Athar, Jaita, Fish. And guys, please turn your camera. If you can, please turn your camera. At least someone. I'm only seeing myself. Okay, first one. Second one. If the negative work done by conservative internal forces is equal to, in last class only we defined this. Very good, Maria. Maria became Afro. Nice, nice. Okay. Okay, true. Okay. Second one, what's the answer of second one? If you remember this, we have used in these two, we have used in last class, right? If you remember, how many of you remember this? Tell me. Work done by conservative field. Work done by conservative field is equal to yes or no? Yes. So this and this, both we have covered in last class itself. If you remember, if you remember this, see, before this, we have covered this concept that work done by conservative field is, tell me, negative of potential energy. Yes or no? How many of you remember this concept, guys? Tell me, do you remember this concept? Anna, see, d is equal to minus f dot dr, which is the negative of work done. Anna, right? So I guess all of you understood this, first and second. Third one, dash of a two particle system depends only on the separation of distance between them. Tell me, kinetic energy, total mechanical energy, potential energy, or which of them is correct? Dash of two particle system depends only on the, tell me, separation of distance between them. A, B, C, D. Anyone? Okay, Snigdho. Right, guys, everyone, at least think, and because these are very basic conceptual problems. Fifth one, the work done by all the forces, internal or external, on the system is equal to work done all the forces, right? Of the system is equal to. This is a basic statement of work energy theorem. Fifth one, tell me, fifth one. What is the answer of fifth one? Are you guys replying on co-host or what? Okay. Yes. है ना? Very good. Correct. Very good, Priyanshu. Very good, Dhruv. Very good. है ना? I hope all of you remember that it is total kinetic energy. Work energy theorem says now. So first is true, guys. First is true. Whenever we talk about conservative field, potential energy is all defined only for conservative fields. That's the first thing that you have to keep in your mind. Okay. Potential energy is defined only for, right? Okay. This. Okay. Second, negative work done. Yes. Second is potential energy. That's what I said. Okay. Third is also potential energy. Fourth, total energy. Fifth, kinetic energy. Okay. Clear? Anyone have any issues? Tell me. Okay. So when you talk about the first concept of this topic, the first concept is basic derivation of center of mass, right? Basic meaning of center of mass. So how many of you watched these videos? Raise your hand. Because if you have already watched these videos now, then yes. Now tell me, don't you think that your concept would be much clear, right? So we have discussed the basic concepts of center of mass. Can anyone tell me what is center of mass? Tell me. What is the basic definition of center of mass? We have discussed it. Yes, very good, Snigdho, very good, Sampada, right? It is the imaginary point, right, where mass of all the bodies, yes, assumed to be concentrated. Means, right, suppose we have a system of an object, or we have a, tell me, continuous mass system. So obviously the mass of whole object will be distributed, right? So for example, when you talk about discrete system of masses, I can say M1 यहाँ है, M2 यहाँ है, M3 यहाँ है, M4 यहाँ है, right? I want a point, okay, I want a point at which total mass will be assumed to be concentrated. So that point is called as center of mass, right? In the same way, when you talk about continuous mass system, the mass is totally distributed throughout the object. So I want a point at which the whole mass is concentrated, and that is your center of mass. Okay, that is your center of mass. So in order to find center of mass, we have to find what? Tell me. I hope all of you remember mass momentum. Yes or no? Mass momentum. I hope all of you remember, right? Mass momentum. What is mass moment? Tell me, what is mass moment? It is the mass of an object that we are, right, that we are taking into consideration, and distance of that mass from the reference point. Yes or no? Right? Yes, very good. So when you talk about this, I've discussed then that if we have mass m1, m2, m3, and if it is at distance r1, r2, r3, where r1, r2, r3 will be the position vector, with respect to the reference point, then the momentum would be, sorry, mass moment would be m1 r1, m2 r2, m3 r3. Okay. Now when you talk about total mass moment is m1 r1 plus m2 r2 plus m3 r3, right? If we talk about individual masses, but if I want to find a point at which the total mass is concentrated, so mass at this point would be what? Total mass, which will be m1 plus m2 plus m3, and since the masses are not different, right? It's not that the object, if we assume the mass at some other point, the moment will change. No, moment will not change. So the moment of all these masses at point B, at point B is given by m1 plus m2 plus m3 into r vector, where r vector is, tell me, the point, the position of center of mass. Okay. So if you have to find r vector, what we can do? Sir, r vector can be given as m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. So this is the formula for center of mass. This is the formula for center of mass for discrete system. Yes or no? Clear? Where r1, r2, r3 is nothing but vectors. So now this is in terms of vector. If you want to find the individual components, I can say x center of mass is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. The same way y center of mass, x center of mass. So these are the coordinates of center of mass. I guess all of you remember this problem that we have covered in last class, yes or no? And no, right? And then when we talk about basic formula for n number of objects, so I can say it is summation of, tell me, I can say it is summation of what? M1 R1 by summation of M1. Clear? Yes or no? Anyone have any doubt in this? Right? Now, when you talk about continuous mass system, so I said for continuous mass system, I can assume that there's a very small segment, very small segment. Let us assume this very small segment. This small segment will be dx. Yes or no? And then in this small segment, there will be a mass of dm, right? Which is x distance from your point of reference. So here, the point of reference, suppose you take this point as a reference. So this is x, right? Now, if we talk about integration, what is integration? Integration is basically summation, continuous summation. Yes or no? I hope all of you know this, right? Integration is nothing but continuous summation. So I can say, sir, summation of MIRI will become integration of XDM, right? Now, what to do in these kind of problems? So we will start with continuous mass system. Okay, we will try to start with continuous mass system. So let us see the example. Okay, so guys, all of you understood the formula of discrete mass system? Hi, Anna. Tell me, all of you, anyone have any doubt in discrete mass system? Can you find the formula of discrete mass system? Raise your hand. I guess my internet is, yeah, internet is fine, right? You guys can hear me, no? Everyone can hear me? Okay, chalo. So let us try to find a very basic object, which is your rod, center of mass of the rod. Everyone, think about it, right? Think about it. So if it is a uniform rod, so I can say with use like without solving anything, right? But just by using common sense. Tell me, the center of mass of this rod should be at which point? Tell me. Should be at this center of mass of this rod should be at which point? Everyone. Think about it. First of all, it is middle, right? Very good, Lohit. Very good, sir. It should be in center, right? If mass is uniformly distributed, so I can say the mass, if it is uniformly distributed, then it would be at yes or no. But I can say, sir, if you talk about this point as a reference point, so it should be at L/2 distance, right? Using your common sense. I guess this is very much clear, very much easy. No need to find it. But suppose if you want to find it, then what? Suppose मुझे नहीं पता है, मुझे निकालना है, right? Then what? Then no issues, sir. We know I'll take this as a reference point. Let us take this as a reference point. So if we take this as a reference point, so let us take this element. Let us take this element as dx. The mass of dx will be what? dm. Yes or no? The mass of dx is dm. Anyone have any issue in this? ये सबको समझ में आ रहा है ना? सबको समझ में आ रहा है ये? हाँ चलो. That if I take a very small segment dx, the mass would be dm. Now I want to find what is dm in terms of x. So dm is equal to what? dm is this chota mass. So I can say, right? There's a term called as mass density. Mass density, है? So mass density can be of different type depending on the surface, depending on the object. Here it is a rod. So I can say here we will have linear mass density. Linear mass density. Right? So what is the meaning of this? It means mass, total mass of the object by length of the object. Yes or no? Raise your hand. Total mass by total length. That is the linear mass density. Agree? Simple unitary method. Now, so I represent it as lambda. So what is dm? dm kya hai? dm is the mass of small unit, which is dx. So I can say it would be total mass by total length into small unit dx. Yes or no? Raise your hand. सबको समझ में आया यहाँ पे? I hope all of you understood this, है ना? This is the linear mass density, or you can just say that dm is equal to lambda dx. So either you can write m by l or lambda. Lambda is generally represented for linear mass density, or when you talk about charges, right? We will discuss linear charge density in the same way. So I can say dm is equal to, I will just write m by l dx. So this is the first thing, first concept. I guess all of you understood this. All of you understood this? Raise your hand. How dm is equal to, right? Yes, Krish, Snigdho, Shrikar, Athar, Omkar, Yashika, Preeti, Jaita, everyone is getting this? Pravalika, है ना? सबसे important dm. Everyone, you have to find dm first, है ना? Okay. Now, what is the formula of center of mass? I know that, sir. Our center of mass is equal to what? Integration of x dm by just m. It is just m because integration of dm is just m, right? It is actually integration of dm, है ना? Actually, it is integration of dm. So integration of dm is just m. If it is not varying, integration of dm, okay, 0 to m. यहाँ पे ठीक है. So it is what now? Integration of dm is just m. I hope all of you know that integration of f of x, sorry, d of f of x is just f of x. Yes or no? हाँ या ना? This is the basic integration. I hope all of you know this integration. Chalo, very good. So I will be left with 1 by m integration of x dx. Now tell me here, right? The integral factor is dm and the variable is x. So can I integrate? Tell me, can I integrate this? Yes or no? You have to know the basics of integration first. Enough maths. So sir, x and dm, right? Obviously the variables are not same, so I have to convert dm in terms of dx, right? I have to convert dm in terms of dx. हाँ है ना? सबको समझ में आ रहा है मैं क्या बोल रहा हूँ? Right? Because when you talk about changes, right? It depends on independent variable. Here it is x, so I have to convert dm in terms of x. How? So ये है ना? हम लोगों ने ये use किया ना? So I will use this. This is m by n. So our center of mass is equal to 1 by m integration of x. Now instead of dm, I will write m by l dx. M by l into dx. I hope all of you are clear with this concept, right? Right, Reshma, Roshni, Rohit, Sanjana, Omkar, Abhilash, Suhas, Mohit. Okay, John. Right. Now m by l is constant, right? M by l is constant now. Right? M by l is a constant. So m by l constant तो मैं बाहर निकाल दूंगा. Integration के बाहर आ जाएगा. So m by l into m integration of x dx. Okay. और कहाँ से कहाँ तक? ये 0 से लेकर यहाँ तक ना, right? So this distance is x. This distance is x, right? So it is 0 to l. X is 0 to l. Now what is the integration of x, guys? What is the integration of x? Tell me, what is the integration of x? I hope all of you remember, right? When you talk about integration of x to the power n, this is x to the power n plus 1 by n plus 1. Yes, very good, Jaita. Very good, Dhruv. Very good. So m will get cancelled. I will be left with what? 1 by l into l square by 2. Yes or no? So 1l cancel. So it is l by 2 RCM. Yes or no? Right? I'm just telling you the method. I'm just telling you the method for rod. Anyone have any doubt in this? Tell me, anyone have any doubt in this? And guys, this is a suggestion. When I'm writing this down, you also start writing. You also make your own notes along with me. Solve it along with me. That would be the best. That would be the best, right? As I'm doing it, right? Take your notes and start solving along with you. ठीक है? Right? बाद में class के बाद देखने की जरूरत नहीं पड़ेगी. So this rod is clear or not? I'm not talking about just rod. The overall concept is clear or not? How to find the सेंटर ऑफ मास, विल डिस्कस सम मोर सेंटर ऑफ मास, ठीक है, एक दो और हम लोग निकालेंगे। ये सबको समझ में आया कि नहीं? टेल मी एवरीवन, डिड यू गेट दिस, यस और नो? Okay, yes. Now let me ask you one more problem, right? Let us see a concept. Okay, everyone, let us see a concept. Suppose I give you a rod. Let us see how many of you can find it. ठीक है, अब ये सबको ही सॉल्व करो एक बार। Suppose this is a rod. Okay, this is a rod, but the problem here is here mass is not uniformly distributed, है ना? Mass is not uniformly distributed. It means that the mass density, the lambda, is actually varying with respect to length, है ना? Lambda is varying with respect to length. So lambda is 5x plus 3. So this is the value of lambda. Lambda is varying with x, right? And the length of this is suppose L. Okay, right? Then find center of mass. Find RCM in this case. Okay, here lambda is not constant. In this case, in this case, lambda was constant, yes or no? M by L was constant. So हमने बाहर निकाल लिया था, yes or no? So here lambda is not constant, right? Okay, so try to find this problem. I will give you 1 minute, and step by step. Everyone try to find it, step by step. Do it by yourself. Try करो सब कोई, step by step लिखो. Right? Start with formula. RCM is equal to integration of x dm by integration of dm. Right? This is a basic formula. Second, dm is equal to what? Lambda dx. These two things that you should know. ये तो हम लोगों को पता है ना? Yes or no? Raise your hand. This we already know, right, guys? है ना? So write this and then try to proceed, है ना? Step by step. Write this and try to proceed. Right. So let us see. Let us see the solution. Those who are solving, please keep on solving. So when you talk about this problem, so still I'm having the value of lambda. So the difference between this concept and the previous concept was that here lambda is not constant. It is a variable. It is a variable 5x, or instead of just 5 and 3, just put the value, right? A and B. General. I'll just take general. Okay. Ax plus b, general value. So what would be dm? Tell me. Dm would be, tell me guys, ax plus b into dx. Yes or no? Raise your hand. Yes or no? Yes or no? So when you talk about numerator, try to find numerator and denominator separately. So when you talk about numerator, so when you talk about numerator, what it would be? It would be integration of what? Ax plus b into x. Tell me, yes or no? Because dm is this, right? And here x dm. So this into dx. This is your numerator, है ना? Normally क्या होता है ना, कुछ लोग ना लिख के काट देंगे, right? So that is not correct, है ना? Some people might just write ax plus b dx, नीचे भी x plus b काट देंगे, तो बस वो बचेगा, वो कभी नहीं करना है, right? So find numerator. I guess this is clear. Now when you talk about this, I hope all of you remember the concept of integration. We will use property 1, which is integration of ax squared dx plus integration of bx dx. Yes or no? Using distributive property, right? 0 to L, 0 to L. Now here a is constant, I'll take it out. A, integration of x squared dx plus b, integration of x dx. So what's the integration of x squared, guys? What's the integration of x squared? X squared integration x cubed by 3. Yes or no? And x integration x square by 2. We just discussed that. Yes. So this is equal to what? A x cube by 3 है ना, कहाँ से कहाँ तक 0 to L plus b x square by 2 कहाँ से कहाँ तक 0 to L. So if you put the value of L, we will get a L cube by 3 plus b L square by 2. यहाँ तक सबको समझ में आया? Raise your hand, everyone. Raise your hand. यहाँ तक सबको समझ में आ गया? Anyone have any doubt? This is your numerator. This is your numerator, right? है ना? चलो, very good. Okay, Bhavna, Dhruv, Maurya, Harshan, John. John, you are getting this? Nazneen, Krish. Krish is not here. Krish is here, yeah.
Yes, sir.
Okay, chalo. Now this is your numerator, right? Now let's talk about denominator. Step by step, अलग अलग निकाल लेना, best है. So denominator is what? Integration of just dm, right? Yes or no? Which is integration of ax plus b into dx. As simple as that, right? 0 to L, 0 to L. है ना? ये तो simple है. 0 to L, a x dx plus b integration of dx. 0 to L, right? Using the first property of integration, right? So it is what? A L square by 2 plus BL. हाँ या ना everyone? मैंने यहाँ पे थोड़ा सा स्टेप रिड्यूस कर दिया. आई एम होपिंग कि ये सबको पता है. dx का इंटीग्रेशन x होता है, L पुट कर देंगे तो BL हो जाएगा. x का इंटीग्रेशन अभी हम लोगों ने देखा, L square by 2. So what is my XCM? Everyone, step by step. What is my RCM? Center of mass. न्यूमरेटर क्या आ गया मेरा? ये आ गया a L cube by 3 plus b L square by 2 divided by a L square by 2 plus BL. Yes or no? हाँ या ना? यहाँ से क्या कॉमन होकर कट जाएगा? L कॉमन होकर कट जाएगा. Yes or no? So if you take L common and right cut it, you will get what? AL square by 3 plus BL divided by, tell me, A L by 2 plus B. So this is the formula of center of mass. Yes or no? Tell me. हाँ या ना? Right? Anyone have any doubt in this? Raise your hand. Anyone have any doubt in this? Right? अगर वैल्यू पुट कर दूंगा मैं, L का वैल्यू, A का वैल्यू, B का वैल्यू दे दूंगा, तुमको सॉल्व करना आसान हो जाएगा. That's why I'm talking about general formula. Right? This is just a problem. Everyone, I hope all of you understood this concept. Raise your hand. Yes or no? Everyone. Because in our today's problem solving classes, we will discuss the problems based on this. Sampada, denominator, when you talk about denominator, it is just integration of dm, and dm is lambda dx. So lambda is ax plus b given. So बस इसका इंटीग्रेशन हो जाएगा. So ax का इंटीग्रेशन क्या होगा? ax square by 2, right? And b dx का simple bx, right? है ना? So after putting the value of x as L, I will get this value. ठीक है? Right? Now, I guess this is clear, everyone. Right? Maurya, Krish, Sanjana, anyone have any doubt? Please note it down, right? है ना? Note करते रहो. Nazneen, Neha, Abhilash, Manogna. Manogna, you will absent in last class. So समझ में आ रहा तुमको? You are getting these now?
Yes, sir.
Okay. Kaushik, Vivek. So this is the concept 1. This is the concept 1. Now let us discuss what else can be there. Let us discuss what else can be there. Now let me ask you a question. Is there, right? Think about it. Can mass be negative? Tell me, can mass be negative? Think about it. Can mass be negative? Yes or no? Simple. Right? प्रैक्टिकली नेगेटिव मास हो सकता है क्या? प्रैक्टिकली, राइट, है ना? थिंक अबाउट इट, प्रैक्टिकली कैन वी हैव नेगेटिव मास? No, sir. What is the meaning of negative mass, right? No, practically it is not possible. But when you talk about theoretically, you know, so now instead of explaining you, right, the concept of negative mass, right, let me show you something. Let me show you something. Okay. Wait, guys. Okay. Let me show you something. Suppose I take this figure. Okay. Just assume this is a circle, right? This is a circle, है ना? Of some mass. This is a circle of some mass m. Total mass is suppose capital M, right? So if I ask you, sir, इसका center of mass कहाँ होगा? Tell me, इसका center of mass कहाँ होगा? So I guess you can give the answer way too easily. Sir, इसका center of mass obviously center पे होगा. Simple geometrical center, yes or no, right? Unless and until the mass, right, the density is non-uniform. If density is uniform, it will be at the center. Hayana. If the density of this, right, object is this disk, this is a disk, hai? Okay. Now let me ask you another question. Suppose out of this disk you remove a disk like this. Suppose you remove a disk like this. इसको हटा दो. इसका center यहाँ पे है, right? ठीक है. Remove this. Now, if you remove this, काट के हटा दोगे तुम, will the center mass remain same or will it change? Tell me. That is my problem. Center of mass will remain same or it will change. Common sense ना, अगर change करेगा, right? Obviously इसे change करना चाहिए, है ना? Right? Okay. Now let me ask you one more concept. What would be the center of mass of this portion? What would be the center of mass of this portion? इस portion का center of mass कहाँ होगा? इस portion का center of mass यहाँ होगा, हाँ या ना? Right? Exactly. और इस बड़े वाले सर्कल का center of mass कहाँ होगा? तो यहाँ होगा, right? है ना? Now tell me one thing. Can I consider this as two discrete objects? हाँ या ना? Because first of all you have to know this ना कि it is discrete object or continuous object, right? तुमको जब center of mass निकालना है तुम as a discrete object तो निकालोगे कि continuous object तो निकालोगे, right? That's the first concept that we have to think, है ना, right? Before using any formula. So sir, I know that इसका center of mass यहाँ है, इसका center of mass यहाँ है, right? ठीक है. So let us take the reference. Reference को तुम यहीं ले लो. This is the reference point. O. Let us take the reference point as O, because you know, right? Whenever we talk about center of mass, it is the distance from the reference point. So let us take reference point as O. Reference at O. Agree? Right? Now, यहाँ पे देखो. I can say, sir, for this small disk, it is removed, right? Can I consider as negative mass? Tell me. Can I consider it as negative mass? Think about it theoretically. हाँ या ना? मैंने हटा दिया, right? So theoretically, I will consider as negative mass. Got it? Yes or no? Tell me. हाँ या ना? Everyone, think about it. Right? Yes or no? है ना? Everyone, tell me. सोचो एक बार. जब मैं इसको remove कर रहा हूँ, if I'm removing this, can I consider this as negative mass? Yes, negative respect to bigger circle. Right? Anyone have any doubt in this? Tell me, anyone have any doubt in this? Step by step concept. Okay, sir, ठीक है, मैंने ये समझ में negative mass होगा. What is my second concept? The first concept is I can say that this is just negative mass. This is just negative mass, है ना? मैं इसको पूरा positive mass लूंगा. I will not consider कि इसको हटा दिया गया है. I will just consider this as mass m1. बड़े वाले को mass m1 लूंगा मैं, है ना? And छोटे वाले को mass m2 लूंगा. Agree? Raise your hand. Yes or no? Yes or no? Right? Now, if you know that the mass of bigger one is m1, which is m, right? So can you find m2? Tell me, can you find m2? If the radius is a, the radius is a, this is a. So this radius would be what? A by 2, Ayana, right? So can you find m2? So yes, m2 will be what? M2 will be what? Tell me, m2 will be total mass by total area, which is pi a square into this chota wala area, right? Which is pi a by 2 the whole square. Yes or no? Raise your hand. Yes or no? Step by step, everyone. Yes. So I can say, sir, m2 is equal to what? M2 is equal to what? Total m by 4. Hi, Anna. Anyone have any doubt in this? Raise your hand. Anyone have any doubt in this? No, right? Okay. Okay. Awesome. Chalo. Now let us just think about the formula. RCM. Now when we talk about RCM, difference तो यही ले रहे हैं ना हम. So RCM का formula क्या होना चाहिए? M1 R1 plus M2 R2 by M1 plus M2. But here this M2 is negative mass. Yes or no? हम निकाल रहे हैं. M2 is negative mass. Yes or no? Right? Yes or no? So if it is negative mass, so instead of plus, what should we take? Tell me. Instead of plus, what we should take? दोनों जगह पे. Instead of plus, what we should take? Minus. I hope all of you understood this concept. अब समझ में आया सबको? हाँ या ना? Raise your hand. Is this clear now? Everyone, is this clear? And what is M1? M1 is capital M. What is R1? R1 क्या है? Reference point यही है. Right? Think about it. Reference point यही है. So R1 is 0. Yes or no? Tell me yes or no. Makes sense. Reference point for this is 0 because sir, इसके center को ही हम मान रहे reference point. है ना? Minus M2 is what? M2 is M by 4 into R2. R2 क्या है? अब इससे ये distance कितना है? ये distance is A by 2. A by 2. Agree? Whole divided by M1 is again total M minus M2 is M by 4. है ना? कोई shortcut formula नहीं. Basics. So I guess all of you can solve. So it is what? AM by 4 negative into क्या हो जाएगा ये? 4 by 3 M. हाँ या ना? M minus M by 4 is 3M by 4. So 4 से ये गया, ये से ये गया. What is the answer? Tell me guys, what is the answer? Everyone. Sorry, this is into 2. Into 2 B na? Right? Into 2. So what's the answer? Minus A by 6. Yes or no? Right? Yes or no? Now here, tell me, when you talk about R, this is only x-axis now? Yes or no? When you talk about R, this is actually only x-axis, because will there be any change in y-axis? यहाँ पे y-axis में कोई change आएगा क्या? यहाँ पे y-axis में कोई change आएगा क्या? No, right? है ना? समझ में आ रहा है? बट अगर मैं इसको यहाँ ना ड्रॉ करके यहाँ ड्रॉ कर देता है, कहीं और ड्रॉ कर देता है ना, तो हिसाब से हमको दोनों कंसिडर करना पड़ जाता. Make sense? Right? But the answer would always be right, minus A by 6 along this line. Okay? I hope all of you understood this concept. Yes or no? Raise your hand. Negative mass concept. Right? Okay, awesome. So let us write some observations. So I can say, sir, my general formula, which is RCM, which is M1 R1 plus M2 R2, I'll just take two objects, right? By M1 plus M2. This can also be what? M1 R1 minus M2 R2 by m1 minus m2 if mass is removed. If mass is removed. Got it? We will use the concept of negative mass. Yes or no? Raise your hand. Second, we know, second concept, we know mass can be written as, right, linear density into x or area density into area, right? I'll just write as sigma. I'll just write area density as sigma. Sigma into area or volume density into volume. Yes or no? Tell me. Yes or no? Mass can be written as linear density into distance, area density into area, volume density into volume, right? So considering that, using this, I can say the formula will become what? Tell me, the formula will become what? Lambda, tell me, everyone. Lambda into x into or x1 into r1, right? Plus lambda, because when you talk about mass density, it will be same now for linear, for continuous mass system. For continuous mass system, right? It would be same, right? Lambda x2, or if it is different, you can just write lambda 1, lambda 2, x1, x2 into r by lambda 1 x1 plus lambda 2 x2. If it is same, you can take lambda common or cut jayega. Yes or no? And same, it will be what? Sigma 1 a1 r1 plus sigma 2 a2 r2 by sigma 1 a1 plus sigma 2 a2. If it is continuous mass system, sigma will be constant. Take sigma common, cut jayega. Clear hai? Yes or no? Yes or no? Everyone, right? So it is not a different formula. It is just a basic concept which can be represented in different forms. ठीक है? यहाँ पे भी same minus minus हो जाएगा. Now, I hope this concept is clear to everyone. Raise your hand. This concept is clear to everyone. Right? And now we will discuss, right? More problems will be discussed in today's tutorial class, but I hope concept point of view से ये concept clear हो गया है. Everyone, this concept is way too clear. Anyone have any doubt in this concept? Okay. तो ये हमारा पॉइंट 1 खत्म हो चुका है ना? जिसने जिसने वीडियोस देखा होगा, है ना? हमारा पॉइंट 1 का अच्छे से खत्म हो गया. Yes or no? Tell me. Now let us try to solve this. Everyone. So what would be the potential energy of system of two uniform chains as shown in figure? Length of each chain is L. Take the reference for gravitational potential at the top of the point, है ना? Right, top of the point. So when you talk about potential energy, है ना? So tell me, for this, what is the center of mass? Everyone. अभी हम लोग बताया, है ना? अभी हम लोगों ने बताया. Center of mass कहाँ पे है? Center पे. Yes or no? Raise your hand. Yes or no? दोनों के सेंटर पे होगा. हाँ या ना? Because it is uniformly distributed. लिखा हुआ uniform chains. Okay. See how we will think about the concept, right? And reference point कौन सा है? Where is the reference point? Tell me, reference point कौन सा है? Top of the point. So this is the reference point, right? This is the reference point. Yes or no? हाँ या ना? Then what's the formula of potential energy, guys? Everyone, remember what is the formula of potential energy? Tell me, what's the formula of potential energy? Step by step. So it is mgh. mgh. Very good, awesome. Now, according to this, what is this distance? According to this point, what is this distance? Step by step. Without. Plus or minus? That is the concept, Sampada. Plus or minus? Tell me. Plus or minus? Minus. Very good, Suhan. Correct. है ना? Very good, Sampada. है ना? So I can say for mass m1 it will be what? m1g minus m1gl by 2, right? I guess all of you are clear in this. In the same way, for second mass it will be, right? Yes, correct. For second mass, right? Awesome. Very good. So what do you think? What is the answer? A, B, C, D. Tell me. What simple concept? A, B, C, D. What is the answer? एवरीवन व्हाट इज आंसर? मैंने एक का निकाल दिया, दूसरे का बस निकालना है ना। सी, ऑसम, वेरी गुड, है ना, राइट, वेरी गुड गाइस। सी हाउ these concepts are easy, है ना। सी, anyone have any doubt in this? Raise your hand. Anyone have any doubt in this? Right? Next concept test. Next concept test. Now think about this one, everyone. Think about this one. Okay, tell me what's the answer, guys. Step by step. Just use the basic formula, basic concepts of very good. Okay, Snigdho. See, first of all, as I told you, है ना, इसका center of mass यहाँ हो जाएगा, इसका center of mass यहाँ हो जाएगा, है ना? Yes or no, right? Think about it. This is recording ना? So इसका center of mass हो जाएगा ये distance पे, with reference of this point L1/2, और इसका हो जाएगा इस point के reference से L2/2. Yes or no? इसके difference है. Now here, right? I guess all of you understood, but here the reference is what? Reference is taken from this. Tell me, right? Ceiling यहाँ से, है ना? So tell me what is R1? R1 का value क्या है? R1 is center of mass of first object from reference point. So R1 कितना हो जाएगा? Step by step. What is R1? Tell me guys, what is R1? Awesome. L1/2. Very good. What is R2? R2 क्या हो जाएगा? बताओ. इस point का reference from this point is this distance. Yes or no? This is the concept. This is the step by step concept, right?
So L1 plus half L2.
Yes, exactly. So it is L1 plus half L2. Awesome, right? And फिर formula use कर देना है ना. ये negative है कि positive? Tell me, it is negative or positive? Sir, it is negative. नीचे की ओर है ना reference है negative. So formula में क्या हो गया? M1G same minus L1/2 minus M2G, right? R2, which is this distance. Yes or no? So answer should be what? Answer should be A, right? The answer should be A. Clear? Guys, clear? This concept is clear? Anna? Awesome. See how we can use the basic concepts of center of mass. Now tell me for this one. This one. So for half disk, as shown in the figure, what could be the possible position of center of mass? Everyone. For half disk. Now here, when you think about it, right? Here, when you think about it, right? Anna. So I can say, sir, if you talk about complete circle, if you talk about complete circle, then this would be the center of mass. Yes or no? Raise your hand. Right? हाँ ना, तुमको निकालना नहीं है, but तुम खुद सोचो. ये lower half हटा दिया गया, ये lower half हटा दिया गया, है ना? So this is x coordinate, this is y coordinate. Now tell me, the center of mass will shift in x axis or y axis. Tell me, here the concept is the center of mass. You don't have to find the center of mass. For now, you just have to predict x axis or y axis. Very good, Suhan. Correct. Very good, Suhan. It is possible. Now think about it. यहाँ अगर हटा दिया गया, so it is symmetrical. Think about it. Don't you think, sir, it is symmetrical along this y-axis? Yes or no? Even if it is removed, it is symmetrical along y-axis. Yes or no? ये पूरा portion हटा दिया गया है. थोड़ा सा common sense use करोगे, थोड़ा सा common sense use करोगे, है ना? So you will realize that, sir, the center of mass will not change with respect to x-axis. Yes or no? Raise your hand. Yes or no? Do you get this? Tell me, do you get this? That sir, center of mass will not change in x-axis, right? Because the portion, right? This portion is removed, it will change in y-axis actually. है ना? So y-axis में ऊपर चला जाएगा. Okay? The answer is what? Tell me. Let us see the answer. Everyone. The answer is B. है ना? On the line joining CD. ऊपर shift हो जाएगा. I hope all of you understood this concept. Raise your hand. Hi, Anna. Right? Just using the symmetry. That as I said. Okay. Right? Now, ये हम लोगों ने कर लिया है. हाँ चलो, ये हम लोगों ने किया. Tell me, yes or no? Calculation of center of mass किया कि नहीं किया? Right? System of points के लिए yes sir, yes sir, है ना? चलो. Now tell me this one. Everyone. Tell me. Think about it. 3 points are placed at the vertices of an equilateral triangle. Find the center of mass of the system, right? है ना? Reference point क्या बोला गया? What is the reference point? Reference point क्या है? कोई reference point नहीं बोला गया है, right? है ना? तुम कोई point ले लो. Take any point. Take this as reference point. Take any point as a reference point. समझ में आ रहा है मैं क्या बोल रहा हूँ? Take any point as reference point. Yes, है ना? Yes, Nico, correct, right? Correct. But now, is this a discrete mass system or continuous mass system? Tell me, is this a discrete mass system or continuous mass system? Or take this as a reference point. Take any reference point. But ध्यान देना, x-axis और y-axis का ध्यान देना, ठीक है? You have to take care of x-axis and y-axis, right? है ना? It is in 2 dimension, right? You have to take care of x-axis and y-axis. Yes or no? So I would prefer if you make this and this, right? Why? Because it will be easier, है ना? Think about it. Axis बनाने पहले you have to make axis. So consider this as y-axis and consider this as x-axis. Yes, yes, correct. है ना? So if you consider this x and y, this will be 0, 0. Think about it. So this mass, ये mass m1 जो है, वो कौन से point पे? Tell me what is this point? ये total distance a है, फिर distance क्या हो जाएगा? Minus a by 2, comma 0. This is how you solve any problem. This is how you solve any problem. Yes or no? Tell me. Hi Anna. Tell me yes or no. What is this point? This point is plus a by 2, comma 0. Y-axis is 0. Yes or no? Step by step. And what is this point? What is this point? Everyone, tell me. सर अगर ये a है, ये कितना distance होगा? a by 2 हो जाएगा, तो ये distance कितना हो जाएगा? I hope all of you know this. What is the distance? What is the height of? Tell me, what is the height of altitude, right? Or basically just height. I hope all of you know. Just read 3 by 2a. That is 0, comma root 3 by 2a. Yes or no? Okay. Now, can you use the concept now? Tell me, can you use the concept now? Can you find? Can you find? Tell me, what is XCM? XCM is equal to what? M1x1 plus M2x2 plus M3x3 by M1 plus M2 plus M3. Yes or no? Raise your hand. Yes or no? Right? XCM. So tell me, what is XCM? यहाँ reference ये है. This is x-axis, right? This is x-axis. है ना? This is a reference point. So sir, M1 into, or M1 is just M. Mass is equal, right? Mass is equal, है ना? So M into a by 2 minus plus here x is 0. So M into 0 plus this M into a by 2 by M plus M plus M. ये कितना हो गया? Tell me guys, what is this XCM? बताओ, what is this XCM? What is the value of XCM? 0. Awesome, very good. So this is equal to 0 because ये और ये कट जाएगा ना, और ये तो 0 ही है. तो 0 plus 0 will become 0. तो XCM change नहीं होगा. Means the center of mass lies on this y-axis. Yes or no? The center of mass will lie on this axis. Anyone have any doubt in this? यहाँ तक सबको समझ में आ गया? Yes or no? I guess all of you understood this till this concept, right? So let us take the YCM. Now YCM is what? Same. M into Y1. What is Y1, guys? 0 plus M into Y2. So M into root 3 by 2A. Ayana plus this M into 0. Why? Tell me. M plus M plus M. Which is what? Tell me. It is root 3 by 2 into 3M into MA. MM cut gaya. Ayana. So it is what? Tell me. It is what? A by, right? Or it is basically root 3 by 6A. Is points there. है ना? इस point से root 3 by 6A ऊपर. So I hope all of you know. I hope all of you know that this is what? This distance is what? Everyone, step by step, tell me. Okay. So see, the answer is centroid. I just calculated everything. But I hope all of you understood. Enough. Okay. So next. This, everyone, step by step. Step by step. Think about it. I guess all of you can solve this now. Yes or no? Tell me. All of you can solve this. Tell me. Yes. Okay. Yes. Enough. Right? M1 is given, M2 is given, X1 is given, X2 is given. Chalo. Okay. So I guess all of you understood. Tell me what is the answer? What is the answer? B. Very good, Suhan. Correct. Awesome. Right? है Very good, Suhan. That the answer is B. सही है. Right? I hope all of you got this. Just put the formula ना. Right? अभी जैसा हम लोगों ने किया. Exactly वैसा ही करना है. Okay. Anyways, today only we'll discuss lots of problems in today's problem solving class. Right? So please everyone attend. So we'll move on to next concept. Right? Next concept. Now, what is the next concept? Tell me. What is the next concept? Everyone. बताया कोई? What is the next concept? Tell me. What's the formula of velocity? Everyone. What's the formula of velocity? What's the formula of velocity? Basic formula. Basic formula of velocity. Right? Yes. So it is basically dx by dt. Yes or no? Hi, Anna. Dx by dt. Everyone? Yes or no? Awesome. Right? Very good. What's the formula of acceleration? What's the formula of acceleration? See how simple these concepts are, right? हम लोगों ने झूठ मूठ का right डर बना रखा है अपने अंदर. बहुत simple concept है. dv by dt. Awesome. Very good. Right? Now think about it. If I'm having, if instead of having one object, if I'm having system of object, right? And I want to find the velocity of that system of object. Okay. So how to find velocity of center of mass? Sir, क्या दिक्कत? दिक्कत ही क्या है? Velocity of center of mass is what? D r center of mass by dt. हाँ या ना? Raise your hand. Yes or no? Tell me yes or no. Right? क्या दिक्कत है? Same concept. Yeah, if I have to find acceleration of center of mass. Acceleration of center of mass is what? Kuch nahi, it's the same. The velocity of center of mass by dt. Yes or no? Raise your hand. Yes or no? सबको समझ में आना चाहिए. Yes or no? Right? And you guys try to note this down now only. ये नहीं class के बाद वीडियो देख कर नोट कर रहे हैं. अभी नोट करो. I'm just writing very slowly, है ना? And just write along with me. Just write along with me. Okay. Okay. So let us see how to find VCM. Let us see, right? Finding, the concept is finding velocity of center of mass and acceleration of center of mass without using any new concept. So let me tell you, or let me ask you, what is the formula of RCM? What's the formula of RCM, guys? M1R1 plus M2R2 by M1 plus M2. Yes or no? Raise your hand. Yes or no? Right? Hi, Anna. So can I say, sir, dRCM by dt is equal to, now since M1, M2 will be constant, so I will just take this outside and it will be what? D. Tell me. M1R1 plus M2R2 by dt. Hi, Anna, raise your hand. Yes or no? Yes or no? Then I hope all of you know second property, right? Or differentiating a second property. This is M1 plus M2 into M1 common dR1 by dt plus M2 common dR2 by dt. Step by step. Anyone have any doubt in this step? Raise your hand. Right? Sir, M1, M2 is constant. तो बाहर आ जाए differentiation से, है ना? What is dR1 by dt, guys? What is dR1 by dt? Everyone. क्या है dR1 by dt? क्या लगता है? क्या होगा dR1 by dt? B. Very good, Sampada. है ना? Sir, this is nothing but V1. It is what? M1 V1. Yes or no? Yes or no? And what is this? What is this? What is R2 by R dt? So it is M2 V2 by what? M1 plus M2. And this is what? This is VCM. अब समझ में आया? हाँ या ना? Yes or no? Raise your hand. Tell me. Raise your hand. Right? Anyone have any doubt in this? So I can say, sir, even if I'm having multiple objects moving at different velocity, I can find the velocity of center of mass. Agree? Raise your hand. Agree? Anyone have any doubt? Tell me. Anyone have any doubt in this? No? I guess this is clear. And same way, what do you think? Without solving, can you say what would be the formula of ACM? Right? Without solving, can you tell me what would be the formula of ACM? Anyone? Tell me, what would be the formula of ACM without solving? Tell me. Yes, awesome, correct. Very good, Sampada. है ना? Same. Common sense, it will be M1A1 plus M2A2, right, by M1 plus M2. Agree? Yes or no? Right, Suhan? Awesome. So anyone have any doubt in this? Tell me, anyone have any doubt in this? Okay, let us revise the concept of, right? Let us revise the concept of NLM. So what is Newton's second law, guys? What is Newton's second law? Everyone. What is Newton's second law? Everyone. F is equal to ma. Or I can just write like this, है ना? F net is equal to ma. But when you talk about this ma, it is for single object. Yes or no? Single object. Right? है ना? Now, if I'm having multiple objects, think about it. If I'm having a system of objects, so can I say, sir, F net is equal to, tell me, m total into acceleration of center of mass? Hi, Anna. Can I do that? Think about it. Yes or no? Yes or no? Hi, Anna. Hi, Anna. Think about it. Right? Anna? Yes, sir. I can do that. I can do that. And when you talk about F net, it is always F external. right? So F external can be written as M total into A center of mass, right? Obviously, this is a vector, this is a vector. Everyone is getting this concept? Tell me, everyone is getting this concept? Ayana, right? Now, can I say the same thing about other parameters? What are the other parameters? Tell me, what are the other parameters? So I can say when you talk about this, sir, when you talk about momentum, momentum. So in momentum, tell me, what about momentum? Right? Momentum is given by what? Mass into velocity? Yes. For what? Single system? Sorry, single object? Right? For system of object, tell me, for system of object. What would be the changes? Tell me, what would be the changes? Everyone. क्या लगता है? What would be the changes? Momentum would be what? M total into velocity of center of mass. Yes or no? Raise your hand. Yes or no? Exactly, Sampada. Correct. Very good. Anyone have any doubt in this? Tell me. Anyone have any doubt in this? Raise your hand. किसी को दिक्कत है इस चीज में? Yes or no? Okay. Now, how this concept is used? How this concept is used? Now let us imagine. Let us imagine. When you talk about this object, is this a point mass? Tell me, is this a point mass? Tell me, is this a point mass? Ayana. No. Right? No, it's not a point mass. So let us see this. Let us see. There are lots and lots of application of these concepts. So suppose I talk about a rod. Think about it, this rod. इसका कुछ L है. Okay? इसका कुछ L है. Length है कुछ. Now if you throw this rod, suppose if you throw this rod, right? Throw this rod, right? So obviously if you talk about this point, tell me, this point, it will rotate or something will happen, right? I don't know how it will be, right? Traveling, how this point will be traveling. But I know this for sure. That if you talk about the center of mass, what would be the path of the center of mass? Tell me, what would be, suppose if you're throwing at this point, what do you think? What would be the path of the center of mass? Tell me. The path of the center of mass is always what? Projectile, like a projectile. समझ में आ रहा है? The path traced by the center of mass is always projectile. Are you getting my point? Tell me yes or no. Yes or no. Right? Because when I'm saying center of mass, I'm actually making this whole right object as a point mass. Because I'm assuming that all the mass is concentrated at the center. So I'm considering every mass to be considered at this point. Right? So I'm considering this as a point mass now. So doesn't matter how the object is moving, the point of right this center of mass, right? This will move in, tell me, projectile. Yes or no? So you can find the range or height or whatever you want. Agree? Tell me, agree? Yes or no? Raise your hand. All of you. Tell me. Anyone have any doubt in this? Anyone have any doubt in this? Right? So let us see one example. Let us see one example of this concept, right? Many problems will be discussed in today's class, by the way, of these concepts only. So let us say one concept check. Okay, so let us discuss one concept of this is a good problem. So I will just discuss a good problem for now. Suppose I'm having a pulley like this, and we have two objects, right? This is of mass m1, and this is a mass m2. And suppose this is going down, this is going up, right? So first concept, the acceleration of these two objects will be same or different. Let me ask some basic concepts. The acceleration of these two objects will be same or different, everyone. The acceleration of these two concepts will be same or different. Tell me. Same or different? Same, na? Very good. Same set. So A in down direction, A in upward direction, it will be same. And here I'm assuming that M2 is greater than M1 because I assume that this is going down, right? So obviously, if I'm assuming that this is going down, so M2 is definitely greater than M1. Yes or no? Right? So the question is what? Question is find acceleration of center of mass. As simple as that. That is your problem. As simple as that. Everyone, try to find this. Think about it. Everyone. देखो यही है ना कि नहीं स्ट्राइक कर रहा है. बहुत बेसिक. Everyone, think about it. नहीं ना Krish, how A? Because masses are different, na? Masses are different, right? How can it be A? Tell me, everyone. See, यही दिक्कत है ना तुम लोगों को. यही अब इतना बेसिक कॉन्सेप्ट है, राइट? बट स्ट्राइक नहीं कर रहा है बिकॉज थॉट प्रोसेस नहीं है. स्टेप फॉलो करो. What is the formula of AC? Everyone, step by step. What is the formula of AC? अभी हम लोगों ने क्या पढ़ा? ये discrete है, continuous. Discrete is the system of mass बात कर रहे हैं. So when we talk about ACM, acceleration of center of mass, we just discussed. It will be M1A1 plus M2A2 by M1 plus M2. Yes or no? हाँ या ना? ये सबको पता है. ये सबको पता है. Yes or no? Tell me. Yes or no? Yes. Here, suppose this is A1. Suppose this is A1. A1 is A. A1 is A. What is A2 then? A2 क्या हो जाएगा? Minus A. हाँ या ना? Right? So ACM will be what? Tell me. M1. Now this is considering as A. A. And A2 will be minus A. So minus M2 A by M1 plus M2. हाँ या ना? As simple as that. So this is basically M1 minus M2 by M1 plus M2 into A. Agree? मतलब बहुत मुश्किल है क्या ये? What is difficult in this? Tell me. Is there anything difficult in this? A third? Tell me. Tell me a third. Are you getting this a third? Or just logged in and watching some cartoon or chatting with someone? What you're doing? People do that. I guess a third is doing that only. Just logged in and doing something. No, na Sampada. No, right? This is what I said, right? This is the ACM, M1 minus M2 by M1 plus M2 into A. Now, how to find this A? I guess all of you already know how to find this A, acceleration of center of mass, right? A. What is A? Tell me. A is equal to, if you talk about this, you can use the concept of NLM. Hai. Sir, I can find like this. If you use the concept of NLM, think about it. Right? M1, I'll just use M1G minus tension is equal to what? M1A. Hai. And here, tension minus M2G is equal to what? M2A. So if you just add them, you just add them, then you can get A is equal to what? M1 minus M2 into G by M1 plus M2. Right? Add them M1 minus M2 G और यहाँ पे M1 plus M2 हो जाएगा. Right? So एक वैल्यू निकल गया. So don't you think what is ACM? Everyone बताओ. अब बताओ ACM वैल्यू क्या है? Okay guys, wait. I just did a very small calculation mistake. ठीक है, मैंने इसको M2 इसको M1 लिया था ना. Right? I'll just मैंने कैलकुलेशन इसको M1 ले लिया है. This is M1, this is M2. ठीक है? Right? That's the thing. This is M1, this is M2. Okay? Right. So this is what? M1 minus M2 by M1 plus M2 into A, which is this value. M1 minus M2 by M1 plus M2 into G. Anyone have any doubt in this? Tell me. Anyone have any doubt in this? Raise your hand. Yes, Nick, you're correct. है ना? So this is what? M1 minus M2 by M1 plus M2 the whole square into G. This is the formula of ACM. अब बताओ इसमें क्या यूज हुआ? क्या कॉन्सेप्ट यूज हुआ? Tell me. Which concept is used? Basic formula ना? बताओ. हाँ है ना? Everyone, think about it. Basic formula use हुआ कि नहीं? The basic concept. And you already know how to find A in this problem. Okay? Anyone have any doubt in this? Tell me. Anyone have any doubt in this? Raise your hand. Anyone have any doubt in this? Raise your hand. No? Chalo. Okay. So let us see. So this concept is clear, right? Now for continuous mass distribution, we have covered this continuous mass distribution. So tell me, there are many objects that we have to find, है ना? Rod के लिए हो गया, square के लिए हो गया, ring के लिए हो गया, right? I will note it down. Homework would be you have to find, है ना? Right? अभी खत्म है, अभी टॉपिक चल रहा है, अभी कल भी चलेगा. Tell me, in this case, what would be the answer? Everyone, step by step. Answer, guys. Okay. Okay. I will give you one hint, right? I will give you one hint. First of all, right, when you talk about disc or ring, है ना? Okay, so I will already tell you what would be the center of mass. For example, when you talk about ring, semicircular ring, है ना? So we discussed the semicircular ring का इस line पे कहीं ऊपर हो जाएगा, yes or no? कहीं यहाँ पे हो जाएगा. What is this distance? That we don't know. That we can, right, derive. I can derive, but for you guys, I'll just write down just 2r by pi. Okay, so I will just write down over here. Okay, for now you can just write down over here. Nah. So I will just note it down. Center of mass of some rigid body. Okay. Now for square, circle, we know, right? For square, circle, we know. The only issue would be ring. First of all, this is ring. Ring. This is ring. So if you talk about the common sense, right? So I can say for rings, the center of mass should be somewhere over here. Yes or no? Right? So this is your YCM. XCM will be 0, as simple as that. Right? And YCM is what? Depending, this is Y-axis, this is X-axis. It is basically 2r by pi. हम लोग इंटीग्रेट करके निकाल सकते हैं. होमवर्क तुम एक बार ट्राई करना. है ना? This is homework. You can try. The YCM would be 2r by pi. ठीक है? For ring. Now for disk, same thing. Disk. This is the same, but now it is disk. It is disk. Semicircular disk. Semicircular. Semi ring. Semi disk. Okay. ठीक है? Same condition. Yes or no? Don't you think it's the same condition? Tell me. XCM should be equal to what? XCM is equal to 0. हाँ या ना? So इसमें भी same concept होना चाहिए, right? हाँ या ना? But why? When you talk about why should be somewhere. So अब देखो यहाँ पे क्या? यहाँ पे total mass distributed है ना? Total mass distributed है. Okay? So this is basically what? Tell me. YCM is 4r by 3 pi. ठीक है? Okay. Now next is semicircular shell. Okay, इसका भी same चीज. X will be 0, Y would be somewhere over here. Okay, so it is semicircular, right, or hemispherical shell, right, where R is the radius. R is the radius of each and every component, है ना? Yes, same thing. मैं बस इसको लिख रहा हूँ. Yes, this is what you have to remember for now, है ना? Right? Homework is you can derive, but even if you don't derive, it is fine. YCM is it is R by 2. R by 2. This is the position of center of mass with respect to this point. Okay, got it, guys? Right? है ना? Now, last is semicircular sphere. Right? Semicircular sphere. So I hope all of you know the difference between sphere and shell. Shell is hollow, sphere is solid, right? I can say solid sphere. So in this case also, I can say that, sir, XCM will be 0. Now YCM, by center of mass, is given by 3r by 8. अब यहाँ से ये position, this position is XCM, so YCM, this position. ठीक है? Got it? So ये you just have to remember. Okay? Got it, everyone? Right? You can derive also, but again, derivation takes lots of time, so it is fine. है ना? Those who wants to derive, you can just derive as a homework. है ना? Right? Same integration of lambda dx, integration of lambda, same concept. Okay. Now tell me, अब बताओ इसका आंसर क्या है? You have noted it down, everyone? Did you note this down? Semicircular ring, semicircular disc, semicircular shell, right, and spherical solid sphere, है ना? Hemisphere. Okay. Now tell me, what is the answer of this one, everyone? What is the answer of this one? For a given system, find the value of d, this distance, right? Think about it. Radius of semicircular is r. So ये center of mass m1 है, center of mass m2 है ना? Right? और ये distance कितना है? r है. उनको दोनों center of mass के बीच का distance पूछ रहा है. Yes or no? So common sense use कर. Everyone, just use your common sense. अभी हम लोगों ने देखा. Yes or no? That when talk about semicircular disk, what is this distance? Everyone, tell me, what is this distance? अभी हम लोगों ने देखा ना डायरेक्टली, क्या था ये डिस्टेंस? सेमीसर्कुलर डिस्क के लिए वो डिस्टेंस कितना है? टेल मी एवरीवन, फॉर भाई, टेल मी. ओके, तो ये डिस्टेंस पता है ना? और ये डिस्टेंस पता है r. सो व्हाट इज डिस्टेंस d? एवरीवन टेल मी. Sorry guys, yeah. So I said that this problem is based on ring, not disk. तो ये थोड़ा सा error है इस question में, है कि नहीं? सबको समझ में आया? Okay, right? I hope all of you understood this error. Yes, if it is ring, the answer is D. है ना? If it is ring, the answer is D. Got it? Right, everyone? हाँ है ना? चलो next. Okay, we will continue this. We will continue this. Right? Today's DPP में ये continue होगा, है ना? That's it for today's class. I hope all of you understood the concept of center of mass. Yes, for ring it is D, है ना? For ring it is D. For ring it is D. ठीक है? Okay, guys. Right? Because we have class also. So 4:30 we will solve the problems based on center of mass. Solved examples करवाया जाएगा, Kahoot होगा और ये पूरा complete होगा. Okay? Right? चलो. Bye everyone. Take care. Bye bye. Yes, today only. Yes, I will send you today 4:30. Okay.